our last review video. I hope you found these helpful. And for this particular one, I'm looking at segments. Review video. So we've talked about finding areas and volumes and angles and such, but there's a lot of segments that you should know. Probably the most important is dealing with right triangles and the Pythagorean theorem. So for example, if I told you this was 3 and this was 5, then you should be able to find that pretty clearly. 3 squared plus 5 squared is x squared. So 9 plus 25 is x squared. 34 is x squared. So x is the square root of 34. Okay, so that's how long that would be. For right triangles, you should also be able to work it if I give you a side or a leg and the hypotenuse. So let's suppose we have this problem where I told you this was 5. Let's do 6. How about that? And now the question is, how long is this? So once again, the Pythagorean theorem, 3 squared plus x squared. You square the 2 legs, add them up, and that's the square of the hypotenuse. So 9 plus x squared is 36. So x squared is 27. So x is the square root of 27. And I would hope that you could clean that up a little bit. 3 squared to 3, both of these are the same. I don't know that that you really need to do that, but certainly if you're going into Algebra 2, you should know that the square root of 27 is the square root of 3 times 3 times 3. And there's a perfect square right there, so that comes out front. Okay, now in addition to the sort of the general right triangle situation, you have 2 special right triangles, and you should be able to find those fairly quickly. So if we have the 45, 45, 90 degree right triangle, 45 degree, 45 degree, 90 degree right triangle, and if I give you a side, and I said this side is equal to 3, and I want to know what that is, you should immediately know that this is going to be 3 square roots of 2. If this were 13, this is 13 square roots of 2. And in general, if you have one of the 2 equal sides, if this is S, and again, we're talking a very specific case, 45, 45, 90, 45, 45, 90, then the hypotenuse is always going to be that side times the square root of 2. Suppose I gave you the hypotenuse. So let's say in this case, still a 45, 45, 90 triangle. But now I'm going to give you the hypotenuse here, and I'll tell this is 7. And the question is, what's the side? Well, it's sort of interesting. If you're going from the leg to the hypotenuse, this is obviously longer. And you're going to end up multiplying 13 by the square root of 2. Square root of 2 is approximately 1.4. So this is about 1.5 times longer than that. Okay? Well, in this case, we're going from the hypotenuse to the leg. Certainly the leg is not longer than the hypotenuse. The hypotenuse is the longest side in the triangle. So we're not going to multiply times 1.4. We're going to divide by 1.4. So the way you work this one is you take the hypotenuse and you divide by the square root of 2. Okay? So x is going to be 7 divided by the square root of 2. Let's throw a new screen up here and do another one of those. So here's your 45, 45, 90 right triangle. And I'm going to tell you this is 10, and the question is, how much is that? So again, you're going from the longer side to the shorter side. So take 10 and divide it by the square root of 2. And yes, you should be able to rationalize, I would hope, square root of 2 over the square root of 2. So this is 10 square roots of 2 over 2, or 5 square roots of 2. You don't know that you need to do that. You certainly will need to do that next year in Algebra 2. Okay, so there's your 45, 45, 90. Let's look at the 30, 60, 90s, because that's the other special case that you should have. So here's your 90 degrees, this is 60 degrees, and this is 30 degrees. So we have like 3 or 4 different possible types of problems. The simplest is if I give you the hypotenuse. Let's say this is 20. Now again, we did this on our earlier review video. I want you to imagine an equilateral triangle. So this is like an equilateral triangle cut in half. Slice it in half, and here's our 30, 60, 90. Okay, well, if this is equilateral and this whole side were 20, then this side would have to be 20, and this side would have to be 20. It is equilateral after all. And so this particular leg right here, this x, has to be half of 20. So that gets you that pretty easily. This is 10. And so hypotenuse to short leg, 10. Now how about to the longer leg, going from here to here? Obviously, this is longer than 10, so we're going to be multiplying 10 by some number greater than 1. The number that appears in this problem is the square root of 3. Square root of 3. Square root of 3 is about 1.7. Okay, so this isn't quite twice as long. In fact, the hypotenuse is twice as long, but this longer leg is 1.7 times as long as this one. Okay, so think square root of 3. You might want to remember 3, 30, right? 30, 60, 90 has the square root of 3 appearing in. Okay, so let's run through that again. Here's a 30, 60, 90. So 90 degrees, this is 60, and this is 30. And I give you the hypotenuse. This is equal to 11. This is immediately half as much, just take and divide it by 2. And this side is going to be 11 over 2. And then times the square root of 3. So go from here to here, and then go from there to there. Suppose I don't give you the hypotenuse, but I gave you the short leg. Well, these are just as easy, I would think. You sort of have to think a little bit backwards. Suppose I told you this was 50. Well, the hypotenuse has to be twice as long, so that's 100. And this one over here would have to be 50 times the square root of 3. Again, I'm noticing you're multiplying by root 3. The hardest type would be if I gave you the longer of the two legs. So let's suppose I gave you this, and I said this was 8. Now we want to go from there to here, but we're certainly not going to multiply by the square root of 3. It's pretty clear, I think, that this is much longer than that. So multiplying by the square root of 3 would stretch it out even longer. That doesn't make sense. We're going to take 8 and divide it by the square root of 3. And then once you have the short leg, you can immediately go to the hypotenuse, just double it, make it twice as big. So that's 16 divided by the square root of 3. Those are sort of tricky problems. But yes, you should know 45, 45, 90, and 30, 60, 90. Okay, what other types of lengths did we contend with? One of the important ones was when you had a triangle and you had a line that was parallel to one of the sides. This was under the chapter on side splitter. And you might want to look in the glossary or in the index and find side splitter. Okay, so where you have this segment is parallel to one of the sides. And if that's the case, then there's some nice proportions that crop up here. If this is 3 and this is 5 and this is 4 and this is x, you can set up a very nice proportion. 3 is to 5 as 4 is to x, and that allows you to calculate that. In this particular problem, you would go ahead and take this proportion. I would probably cross multiply. 3x is equal to 20, so x is equal to 20 thirds, and that's how long that would be. Okay. Another variation on this is, again, we have this idea of a side splitter. This time, let's suppose I told you this entire side is equal to 20, and this much is equal to 7, and this much is equal to 8, and now your task is to find that. So again, the proportion, very similar to what we did over here in the red, it would be 7 is to 20, 7 is to the entire side, as 8 is to x. So once again, cross multiply. 7x is 160, so x is 160 divided by 7. Okay, side splitters. There was a special type of side splitter that happened to connect the midpoints, and that was called a mid-segment. And again, you might want to look at that, a mid-segment. So mid-segment, you have a triangle, and this third side is again, or this segment is again going to be parallel, but it's a very special type of side splitter. It connects the midpoints. So this, let's put some labels in here, A, B, C. So M is the midpoint of AB, and N is the midpoint of AC. And now this segment is called a mid-segment. What's so special about it? Two things. It is parallel, so it is like a side splitter. But more importantly than that, this mid-segment is exactly half the length of this other side. So if this side were 10, this mid-segment has to be 5 every time. Okay, so that allows you to do some real quick problems. If I were to give you a triangle and it were marked so that this were a mid-segment, right? And then I told you, for example, that this was equal to 8, you could immediately tell me what x is. It has to be twice as much, 16. If I gave you the longer one, and let's say the longer one was equal to 11, and I said, how long is that? It's immediately half as much, so 11 divided by 2. Okay, so that takes care of various types of segments in triangles. And the last type that you should be aware of, sort of a special type of problem, if you have a circle and if you have two secant segments, and we label these A, B, C, and D as those lengths. There was one special proportion that seemed to be true. This was way back in the secant segment section, page 517 if you've got your book, page 517. 517. And this is what it says. If you were to multiply A and D together, A times D, that's always going to be the same as multiplying B and C together. The proof was actually in the exercises. It had to do with similar triangles. We don't need to prove it necessarily, but you do have to know how to use it. So let's put some numbers in here and see if you could work this out. I could give you any three of these and you could immediately calculate the fourth. So if this is 5 and this is 8 and this is x and this is 10, and your task is to find x. So multiply the 5 and the 10 together. 5 times 10, obviously 50, and that's the same as 8 times x. Okay, so 50 is 8x, x is 50 over 8, or if you want, 25 over 4. Okay, so intersecting chords, think of these as secant segments, if you will, where they cross, and there's a nice proportion setting up there. Okay, so there's all our segments. I wish you luck tomorrow. Make sure you come early, don't come late. I'd rather be here 5 minutes early than 5 minutes late. Bring 2 or 3 sharpened pencils with erasers. Make sure you have your compass and straight edge for the construction. You will have to do the construction of construct the N-circle. And you should have a calculator. I don't think you'll need a calculator. You could use it for the entire test if you wanted approximations, or if you're just, are brain dead after studying and you can't do 5 times 10 and you want to do that on your calculator. You're permitted to do that. So calculator, a compass and straight edge, and 3 or 4 sharpened pencils. Get a good night's sleep. Have a good breakfast. See you tomorrow morning at 8 o'clock. Bye.